Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at domain and range, specifically looking at algebra through calculus. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight we're joined by our two panelists, Kim Thomas and Corey Bobby. Kim is in her 25th year of teaching high school math and is passionate about using technology as a tool to explore and understand math. Kim is currently teaching geometry and BC calculus, and she has 4 years of experience as an AP calculus reader. Kim is a national board-certified teacher and a T-Cube national instructor. She enjoys working with teachers, helping them to incorporate effective strategies for teaching with graphing technology. Kim, thanks so much for joining us tonight.
Happy to be here.
And Corey is in his 21st year in education and is currently working as a math specialist with 22 school districts. Previously, he taught geometry through AP Calculus, and since joining the T-Cube community in 2001, he has worked on curriculum development and workshop instruction, as well as creating online courses and videos for TI-Nspire technology. Corey, it's great to have you with us.
Great to be here, especially since I feel like I visited 22 schools in the last 22 days.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Kim or Corey using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, try selecting Communicate from the very top of the WebEx menu and then choose Audio Broadcast. At this point, Kim is going to discuss our agenda.
All right. So we are in the process of doing our welcome and introductions. And then we're going to move into talking about the calculus mathematical practices. In fact, that's mathematical practices for AP calculus and how they connect to domain and range. We're going to look at piecewise functions and how that connects with domain and range. We're going to connect transformations of functions to domain and range and how that brings up some interesting questions. We're going to look at domain and range and its influence on AP calculus free response questions. And then we're going to explore some rational functions and some domain and range issues with those and how they look like on your calculator. And then as the finale, there's going to be a drawing for all of those who are still here at the end for a free registration for the T-Cubed International Conference that will be in Dallas.
Thanks so much, Kim. A lot of domain and range, but I think that's what's expected tonight. So, Kim, it's all yours. Feel free to share your screen.
Okay, so I'm going to share my screen right now. And we're going to go ahead and I want to ask a question to the group. When you think of domain and range, what does it first look like in your classroom or in any classroom that you visit, depending on your role?
I know I visited some classrooms this last week. I'll talk for everybody since everybody's muted. I saw a lot of bubbles and tables and function machines, and I saw a lot of students who had puzzled looks on their faces.
So as some people are bringing in some things from the chat, I'm reading ordered pairs, I'm reading verbal descriptions, using other software to just kind of display some things. Examples start out on the coordinate plane. There's some examples that we see. And when we first started talking about this, I really just kind of looked at some different ones. And I know that I would start out with the definition. My definition of domain and the Cartesian coordinate plane and the definition of range, and really kind of getting in with my students any misconceptions that they might have with range. Like, is it a golf range? You know, in high school we have golf players and it's golf season right now. Or are you really looking at values on a graph or in a table? talking about those presentations that people are listing in the chat. You know, you have mappings between numbers, and even understanding what this graphic looks like over here on the left. Usually we connect domain and range to what a definition of a function is. We see tables, and those were things that were definitely listed in the chat, and then ordered pairs. I see lots of things of ordered pairs. I see an example about a function machine and mappings, diagrams, coordinates, and then how are you listing your domain and range? So I know some people said verbally, but are you using set notation? Are you using inequality notation? Are you using interval notation? It really does change at each level. And so this is kind of just a classic example of a graph of a function. And we would ask, what's the domain here, or what's the range? My favorite is to actually give a domain and range and have them fit a segment inside of there, and then kind of change it into a different function. That's actually a really good favorite of mine. And then hopefully we're talking about contextual relationships, meaning that if I give you a situation and it's about temperature and what temperature about baking something, and there's a temperature change, hopefully we're not getting into negative numbers for that temperature, because then we would be freezing, and in the context of cooking that would not be appropriate. So there's those extensions that go with that. We just kind of wanted to get your ideas going, and we are now going to kind of look at an activity on the TI-Nspire. And Corey is going to share that with us.
Okay, so I'm going to share my screen now if you would. Okay, so you should see my browser. I'm sorry for those of you who aren't big fans of dark mode. I'm getting used to it right now. So anyway, I want to quickly show you where you can get some resources for the Nspire. I'm going to be the Nspire tonight. Kim's going to be the 84. We're going to bounce back and forth quite a bit. And so if you look under Algebra 2, we go to mathinspire.com, and then go under Algebra 2 and under Functions. There's one of the classic Math-Inspired documents called Domain and Range 2. There's another one in the Algebra 1. This one's a little bit more, you can download all the files. There's a student activity that comes with it. I opened it up here. And it's student and teacher notes. And there's the, so here it walks them through it. You can break this down any way you want. But you can also download the document, and the document looks like this. So the first few pages, and I'm going to kind of go back and forth between the Word document a little bit, just quickly, not go through every part of it. But you're going to drag point P and record the values in the table here, and that's going to help build the domain and range. So if I grab point P and move it, it's leaving a breadcrumb trail along the x-axis. And I particularly like these 2 points right here because it doesn't leave any more breadcrumbs, but that's another issue you're going to have to talk about with your kids. And so the students could then go here and see that it's -4, 0, 2, 3, and 5 on the x-axis, and then along the vertical would be whatever these are, 4, 3, -2, -3, and -5. So, and there is a reset feature here. So it goes through and walks them through different examples. This one is a set of distinct points, and then we could go on and see the effect of dragging it along a piece of a polynomial, and it leaves, again, this time a continuous breadcrumb trail. You saw a little bit of the Nspire functionality there about the zeros and the maximums, going along both ways to trace out the entire domain and range. And again, this is all supported with student documents. And then I'm going to skip down to, I think it's, as I was looking through this document, there's one of my favorites here is at, scrolling down to, I think it's page 6.1. This one, we want to drag it so that we have a certain fixed domain and range. So I could challenge, this is what Kim was saying. Kim, give me a domain that you would like to see me create.
I would like a domain from -7 to 2.
Okay, so I have to figure out a way to drag it. So kids might want to make it be down here, 3, 4. Oh, good. But anyway, I could drag it down. I think they can go off the screen to get -7. If I'm thinking kids will mix it up, but a -7 to 3, is that what you said? So I have it now.
I said 2, but 3 will work.
Yeah. So, but anyway, after the next way is to make a graph that make certain things. I also like the fact, and then that leads to the discussion, is this the only, this may not be, because if I wanted to, I could go up here, -7, make this down here, and I still have a domain of -7 to 3. So there's lots of different solutions to the problem, and getting kids to see
What's
that
nice,
not every.
What's also nice about this particular activity is that it forces students to think about things, because I'm looking at the screen right now and I was not very clear with you. If I wanted my domain to be an open -7.
Right, now I can't change that on this one.
But you can. So what if I want my -7 to be closed and I want my 3 to be open? What would you have to do with that green segment?
I would have to, I'd have to go this way, and
that,
this way.
And that flexible thinking for students is so very important, that they go, oh, I can just flip the segment around and make that work. So for them to notice those closed points and open points it's really nice in the classroom with the navigator system.
True. Yes. So I thought you meant both closed, but I can't change the layout in this file. Do that, but this is an easy. But that would be an easy fix if you wanted to. So, and then, so here's question 7 in the handout, and this kind of goes along with it. Is if we go into question 7, it gives them some scenarios where they're dragging those points to make certain criteria. So all of that is written out here that can allow you to do some of that productive struggle, that what if kind of scenario work with kids. So I don't want to belabor this point, but I think we do have that power in here. So this one is specific. I think I jumped the gun a little bit on number 6.1, but you can play the what if game. But I also would really love to have kids then follow this up by drawing this by hand with a nonlinear function. Could they connect this? And I could see a scenario where a student might try to connect these 2 points, but go outside. So if a student drew something that went down here and then reached back up to the +3, then they realize they still have the domain, but they would then have influenced the range. So if you give them restrictions on both domain and range, then they have to be careful to stay within both boundaries. And that's something that I've experienced with kids. I've done several different projects with domain and range, and I know I had one. This is the best story I've ever had with a kid. The student was working on a project that I gave him all night, and he came back the next day and said, Mr. Bobby, it took me 3 hours last night until I figured out I could control the y by changing the x. Like, haven't I been saying that for months? So sometimes they just need to make that process their own. So, anyways, I'm going to transfer this back to Kim so she can take us into.
Hey, before you do that, just do one favor for me, because you gave me an idea that I've never done with this file. Go ahead and press tab. So when you press tab, do we get the function line?
Yeah.
So you could put your function on top of that, which is, like if you just wanted to do x² and then restrict that so that it would work.
X².
That's wonderful. And then we'll get to the rest of it from there later on in the webinar, but or you can show it now.
-7. Oh, pick your thing here. Come on, Corey. Hit tab. X². Yeah, Kim is ad-libbing on me. Sorry. X².
Sorry.
That's okay. That's the best. Sometimes that's the best.
I've never thought to do that. And you said something that just sparked that in my brain.
-7. And we're going to do this here in a moment. I'm just doing it the long, hard way. So I want to do less than or equal to 7. and x is less than, what was it, 3?
3.
So now, yeah, although I do have issues with my range
Right.
being off the screen,
But that's
so I
a good
can't
place
see it.
to start.
That's a good place to start.
Yeah.
I'm seeing, so yeah, that's interesting. I hadn't thought of that either. So I love how we prompt each other sometimes. So.
Absolutely.
Okay. So, okay, let me go ahead and assign this back to you.
Okay.
And you're going to take us through a modification, I think.
So what I'm doing right now is, well, let's go ahead and connect this to the mathematical practices just a little bit. And these are the mathematical practices that are in the course exam description guide for AP Calculus. And they really do connect to the mathematical practices that came through our Common Core standards. One thing in particular, like I'll just start down here, use appropriate graphing techniques. So we're using technology to do some things, but we've mentioned that I want kids to do this by hand. I want them to whiteboard some things. I want them to practice on other mediums. Up over in here in connecting representations, which I think is a key to domain and range, is identify how mathematical characteristics or properties of functions are related in different representations. So connecting the domain and range of a function, and then how does that domain and range change if we were to look at an inverse, for example. So that's a different situation. A different representation would be if we did the mapping, and then you had the inequality notation, and then all of the other ones, especially working with the tables. Another representation is identifying mathematical information from graphs, numbers, analytical representations, and verbal representations, which is what we mentioned in the beginning. So that's just inherent when we teach domain and range, that we're kind of addressing that particular standard. Over here in mathematical processes, identify key and relevant information to answer a question or solve a problem. So in contextual situations, we kind of have to address the relevant domain. Is this answer appropriate for the situation? Would be something that definitely starts well before high school. And then the last one, you know, when we talk about domain and range, it shouldn't just be in isolation. It should be in the context of some type of situation. So is this a reason for my answer or rationale? So we just picked these ones to kind of highlight, to kind of think about as we're moving forward. So I wanted to kind of bring that up. The other piece is that we need to do some graphing on the TI-84. So what I'm going to do is I'm going to graph this particular piecewise function. And so I'm going to bring up my TI-84, and I want to do this graph. So just as a quick poll, you can say yes or no. How many out here know how to graph a piecewise function on your TI-84? And I'm going to qualify this without a trick. Like, you're not going to divide by 0. You're not going to have something hidden. You know the new notation that works with our TI-84 plus CEs. And so I'm seeing some no's, I'm seeing some yeses, I'm seeing some maybes, which is pretty good.
I think they're trying, if they do know, I'm guessing many of them know your trick way.
Yes, I'm thinking they do too. So we're going to go ahead and graph this. So I'm going to go into y equals. And inside of math, and this is the part that I think that's kind of hard about this, is that you have to go up until you see the option for piecewise. So we have the option for a piecewise template now with our graphs. And I'm going to select it, and then I'm going to ask, it's going to ask me how many pieces would you like. It defaults right here at 3. And I'm going to change that to 2 because my example here has 2.
And by the way, this is an 84 CE, not an Nspire.
Yes, this is
Sorry,
the TI-84
I'm responding to
CE.
chat for you. You keep going.
Okay, that works. And so now I'm going to type in my function. So my first mathematical rule that I have here is going to be x squared minus 1. And I'm going to hit the arrow over here, and I'm going to type in -1. And in order to get this inequality, I have to hit second test. So inside my test menu is when I have all of these operations here. And so I chose to do less than or equal to 6. I'm going to press button 6, I should say. And then I'm going to press my X, and then I have to do second test again, and I'm going to do less than or equal to, and I'm going to have a 2. And my second rule for this particular piecewise function is negative X, and it's going to be plus 5. And we're doing that for 2. Again, second test. We're going to go with less than, which is 5. We have X. And we're going to go with less than or equal to, and we're going to do a 5. And some things that I would ask my students in my class, you know, what is the domain that we're going to see? What kind of window should we have? I'm starting from a clean calculator right here, so I'm just going to press graph, and I see that picture. Might not be the prettiest picture that I want to see, so I might want to zoom in. That's a common thing that people will do so that you can see a better graph, but that didn't really quite work. So I'm actually going to, yeah, they can always zoom in and zoom out, but that might not be always the best thing. It's usually better to think about it. I'm going to go with zoom decimal. And one question that I would love to be asked all the way throughout the curriculum is this a continuous function or not? So we talk about increasing and decreasing, and we talk about zeros, and we talk about intercepts at all levels at high school, but it's sometimes that continuous piece is sometimes missing. And my next follow-up to that would be, how would you know? And so one thing that we could do with this graph is we could trace it. And I want to start over here at -1. And it is telling me that it's -1, 0. Yes, go for it. Okay.
No, I was just going to say my kids would say it's it looks like it's continuous from -1 to 2, and then from 2 to 5. Some of my algebra kids, I'm guessing there's something. I was going to chime in. They would say something's funky going on at 2, so it's not continuous there.
Right, it's something changed there, and that really is what the problem is. It's like, well, it's equal to up here in my first rule, but it's not equal to down here. And so the question is, well, did they meet up? And that, that really is the big question here. On this one, it looks like they met up, right? And,
yeah, but but not like any graph I've seen before. Sorry.
Right, at the freshman level, definitely not. And even when we discuss this at the calculus level, there's always that question, well, which rule did that work, and how do I graph that, and how do I put those things together? It's been a while since we've done that. What's kind of cool about this is I'm going to go ahead and switch to the table view right here. So again, on my TI-84 CE, I can look at this. I changed my mode as a graph table. And this is my favorite view on the TI-84 because it allows me to look into my table here. So if I'm in my table here, I can trace my points, and I can see visually right here that I don't have an input here at -3, and I don't have an input at -2, but I did start at -1, which matches the function rule I have over here on the left here, which I think is pretty cool. So that also connects back to our mathematical practices. I have different representations. So I have this table view of my function, even though it's discrete points and not continuous points. And I also have this graph view here that we're looking at, which is pretty cool. So that's something to kind of think about, and we can also check some things. Now, Corey, were we going to transform this graph a little bit too?
If you want, or I can do that with mine on the Nspire. Or you want to show them how it looks on yours? Why don't you do 1 or 2 with yours, and then I'll.
Yeah, we'll do 1 or 2 here. I'm going to change the format on my screen real quick, and what I want to do is I want to turn on the grid, just because I think it's a little bit better, and I'm going to make this bigger now on the screen. And so one way that we could transform this, how would you like it transformed first?
I would like to go down 2.
Okay. So we're going to go into Y2, and if we're going to do a vertical shift down, I'm going to hit alpha, and I always mess this up. I don't know why I had messed this up every single time. So it's alpha trace. I have a 50-50 chance. And I'm going to do Y1. I know, and I always,
oh, no.
That didn't work. Oh, no.
Yeah, you put it in Y1.
I did.
Well, maybe
I put it into Y1. I think we're going to switch on over, and then I will do it over here.
Yeah, you go and put the equation back in, and I'll do the next example on the Nspire and parallel this on the Nspire while you reconstruct the problem.
I think that's a great idea. All right, I'm sharing with you right now.
Okay, so let me share my screen. And so if you didn't recognize that question that Kim did, it wasn't exactly the nightmare of the L'Hopital's rule question from a couple years ago, but it was actually a graph similar to a graph from the 2018 AP exam. And this question was from this year's test, and really I'm only concerned about the graph. So what I'm going to do is make a new document because I was left when I was left with the domain and range. So creating creating piecewise function on the Nspire is a pretty simple process. And somebody called this a lobster button or something, the math chat or whatever. But the button on the Nspire, you have what I call the math button or math template button. It's the button immediately to the right of the 9. And you have a bunch of options in here like an equation editor. And I'm going to create the graph on the right. So I want to look at the template that looks like what I'm expecting, and it looks like this is kind of what I would expect it to look like if I were an algebra student. So when I pick this, it asks me actually how many pieces I want. So how many pieces are in this graph, and I actually could change that up and down. By the way, on the one Kim was doing, you could only change it up to, I believe, 5. Is that right, Kim? I think it's 5. But anyway, now I have a piece. Yeah, I'm pretty sure I'm right on that one. But I've got negative x minus 1. I've already derived this equation. And if I hit tab, I can do negative 2 less than or equal. And the nice thing is I'm typing this from my keyboard, not going to the templates. I could go into Control Enter to get the templates. That's what the kids would do on the handheld. But on your computer, if you're typing like me on my computer in my office right now, I can just do it by using less than equal, and that converts into less than or equal to. So 2x minus 1, not 11, and this is 0 less than x less than or equal to 2, about 32. And finally, the last piece was 3 minus the square root, and I only know this because when I was grading this year, I saw a lot of students actually derive this equation. Wasn't the most efficient way to do this problem, but they did it. And this is the bottom quarter of a circle. Kim and I are both AP readers, by the way, and I did grade this question, and it was quite painful at times. Did you grade this one?
I did not grade this one. I was on a different flow because I graded the BC exams. So I only got to see one AB question.
Okay. Well, this one, here's the equation. And one of the things I like about the Nspire is that it does give me the equation and the graph on the same screen. However, I don't actually like it in this case because it takes up so much real estate. So I can right-click on it and choose to hide it. All right, so this may not be the best representation of the graph from ABBC3 this year, but it's what was on what the calculator gives me. And so to piggyback on what Kim was trying to do, and hopefully I won't erase it, here's my equation, and I'm going to go back down to F2. What I'd like to do, and I think I asked you to transfer it down 2 a little while ago.
That's correct.
So what I can do F1 of 2 to transfer a function, translate a graph down to, I would subtract 2 at the end, and then I would get the transformation of the parent function transformation down 2. So I can do that using the labels and getting that there. So since I chose down 2, Kim, what do you want me to do next?
I would like to see it go left 3, and you can
Left
start
3.
with your original. Yes.
Okay, start with my original. Now, I could have transferred my next one down. I've already moved it down 2, and I can move that over so I'd have a combo transformation. But I want to also ask, and I'm not looking at the chat right now, what is the domain of the function? Before I do what Kim has asked me, what have I done to the domain of my original function? I'm going to pause here for station identification. So if you're in the chat, if you're still with me, I saw it pop up, but it hasn't changed. Thank you, Jamie. So I haven't changed it at all. So let's make a prediction. If I do this, if I go back to my original function, and I want to transfer it left, you said left 3, right?
Left 3.
Okay, so this is what every child will do. And
yes, that's what they will do.
That's what they will do. So if I do this, what would a student anticipate the domain would be? Regardless, I know you all know, right, that this is what's going to happen here. But what will the student think the domain is going to be if we take the blue graph, the original graph, and move it left 3? What should happen if we were at -2 to 5 originally? It should be what now? If I'm don't look at what I actually have there, but what if I move it left 3? It should be correct. -5 to 2. Thank you, Mike. So I'm expecting I want it to be from -2 to 5 on the x-axis. Thank you, Mike, a couple other people. Is this graph that I have received going from -2 to 5 on the x-axis? I'm probably going to hide this graph because it's not very helpful right now. And clearly it's not. It's going from 1 to, I think, 8. Bad color choice here, so I might change the color. I'm going to use pink if that's okay.
And I would this would be another opportunity to show, like, I would dash mine so that they can see that this is the different graph on the Nspire. I like that attribute when you go down and, yep, that's the one I like.
Okay, so I expected.
Beautiful.
Yep, I like the contrast in pink and blue because I like pink. Anyway, I expected if I wanted to go left, I know my left from right. I may not know my math, but I know my left from right. So if I go left from -2, I should be at -5. So this is clearly not right, and we have all those discussions. So I can go right in here, and eventually, with a little exploration, the students can then maybe settle to this, okay? So I like that transformation piece of it and using the domain, asking the domain about domain range before doing transformation, particularly with the horizontal transformations. So I think that gives us a good visual for them to do a what-if scenario. So,
let's go ahead and do one more transformation. There's a couple questions about changing attributes, so we can highlight that one more time.
Okay.
So I'd like to vertically stretch it. And if I vertically stretch it, the question is does the domain or range change when I vertically stretch it?
Okay, good deal,
good deal. Well, let's just stretch by 2, a factor of 2.
Let's stretch by, you want to do, so 2f1 of x?
Yeah.
Okay, all right. And I'm going to hide what I'm doing here, and I'll be a little more explicit with this. And so this guy is now a vertical stretch. And have I changed the domain at this one?
No. And what's nice is that we could really box in and see that you have one endpoint and another endpoint that are parallel in the sense that they're on top of each other.
Right. If I were to do menu trace, I could trace. When you're on a graph, right now I'm on the original f1 of x. I can see the maximum is at 1, 3. If I press the up arrow, it takes me to the other function. So I was at 2, 3, and when I jump to the other one, I'm at 2, 6. So now my range is 6. well, I get the maximum was at 6 and it was at 3. If I go back to the original function and down to the minimum at 0, -1, so my range would be -1 to 3, and in my new stretched function to be -2 to 6. And I also can go out to the, oh, wait a second, I can't. Why can't I get to where I want to go, Kim? I want to, it like jumps, doesn't it? So how do I get to where I want? Well, I can type it in, and it'll take me directly to that point. Okay? And that's the same on the 84 or the Nspire. You can jump to any point. What I'm doing, though, I'm going to get out of trace mode. For those of you who were asking to change an attribute of a graph on the Nspire, you want to hover on it. I'll say this, you want to point at it. I say that point at it in class, but with you guys, I say you guys can give it the finger when it's giving it there. So if you press, if you right-click on it or two-finger click on a Mac, or if you're on the handheld, you press Control, then the menu key. You're going to open up a context menu. So if I right-click on it or two-finger click if I'm a Mac person, then I can go in here and change the attributes, and that's where I would go in and change the thickness. I can have it be a thin or a thick or medium weight. So this is a quick way for you to lose weight. You just got to go in and change your attributes. You can do a continuous, dotted, or dashed. I agree with Kim. I personally prefer dashed, but it doesn't really matter one way or the other. You just, to activate that choice, you press enter, and it will accept that change. You could also have changed the color there, but I like pink.
Right.
So, okay.
It shows up really nice. Cool.
Yeah, I do like the contrast, and I do like that I could even. I was kind of interested when I did this f1 of 0.5x. Like, no way, this clearly isn't going to work. Sure it does. That was kind of cool to me. I was like, but the original function, no, it's messing with, it can handle, and now we're getting into horizontal transformations as well. Now I have messed the domain, and that really comes more often. You see this with trigonometric functions, but if you do a horizontal dilation by multiplying within the function notation, you get that same backwards thing that you expect, like with the horizontal transformations. And they don't see this because if we try to do a horizontal parabola, it still looks like a parabola. So this one, I think, is, doing some of these weird monster type graphs is something kids need to get used to and see experience. So, Kim, did you reconstruct that? Do you want to show them the stuff on the 80?
I did reconstruct it.
Okay, well, let me give you control back so you can give them show them what you were doing and how similar it is on the 84. All
right, so there's my 84, and I have my piecewise graph again. And just as a quick review, maybe for some of you, I went into math, and I went up to piecewise, and then I selected that template. So I'm going to go back into y equals. I'm going to be down in y1 here. And what would you like to have happen with this graph?
I guess I think you said that down to is where we started to begin with. So let's go ahead and do it. Yeah.
So
and
I'm going to do y1. Go ahead.
No, I like that you're using the function notation with y1 here. So you can, some people are like, I've done this with other teachers, like, can't I just do y1 minus 2? Yes, you can, but this really drives home the function notation, and it is what's necessary if you want to do horizontal transformations well. So I encourage you, yes, I don't have to have that parentheses of x in this particular problem, but you can, to do all the other things I did, anything horizontal, you would.
Absolutely. And it's the same notation as an Nspire. So I have some teachers at my school where they have mixed classrooms. They have Nspires and 84s in the whole room. It's really the same thing. You just have to say it just slightly different. Instead of F1, it's Y2. I'm going to change some things over here first. So I slid over to this red. I'm going to keep the red. What I'm going to do is I'm going to change my equation. I don't really know if I want it dashed. I'm just going to put that on there. Just as a reminder, this is how I would change the attributes on an 84. And I'm going to go ahead and hit graph. And so there's my blue equation, and here's my red function. And as promised, the domain did not change. I do have my table over here, and so if I'm looking at my table, I can move on over and see the Y2. So I can compare that table on the Y1 and the Y2 still in that mode, which is kind of good. And then we can change something in here as well. So I'm going to go ahead and insert, and I'm going to do the +2. See if I can get this off my screen. Just as a quick reminder, so now we've translated it here. And again, if I go into my table, and I'm just selecting the table here, now I can, no, I did not. Second table. So when I'm over here in my table, I can compare and see that the domain and range changed. So I have to be over here in my X's to see those values. And that's kind of cool, is to look at those tables and that different representation for the graphic that's on the screen. So are we pretty good with this example?
I think so. I think we've looked at the different calculators and shown that it can be done either way.
Okay, and I believe that you are going to do a free response question now?
Yeah, I think that it's my turn to do a free response question, so if you want to give me control back.
I will share back to you. All right, there you go.
Okay, so let me go ahead and share my screen. So, y'all, this is another AP question from this year, and this was AB2 from this past year. I did not grade this question, but as I went through it, I was looking at questions and how the first of all, I just wanted, if you're not a calculus teacher, don't be freaked out. We're not going to do the whole thing. I want to focus on part C, and I want to focus on this equation and notice that it has a domain restriction of only 0 to 4. So this scenario, this equation, this crazy equation, whatever it may be, and it doesn't have to be a trig equation, but I wanted to read this question. So we have a particle Q that moves along the x-axis with the velocity from 0 to 4, times 0 to 4 is given by this trigonometric combo weird question, meters per hour. Part of the question is, find the time interval during which the velocity of the particle is at least 60 meters per hour. Now, none of this to this point is calculus. This is just, we have a function. When is this function going to be at least 60 on the y? So what I want to do is I want to see this picture because I don't really even have a clue what this graph is going to look like. So I'm going to type in the equation 45 times, I need the square root, so I'm going to go in here and put the square root symbol. Come on. There we go. No, I don't want the square. I don't want the square root. Get it from here. Square root of t, well, sorry, I need to use x, times the cosine of 0.063 x squared. Okay, so I have no idea what I'm going to get, but the calculator can handle this for me. And I have a problem here because I've got a graph that's not very helpful, but I also, if I look at my graph, it's continuing beyond 4. So if I arrow back up to this, I can put a domain restriction on any function, and this is what Kim was talking about. If you knew how to do it on the 84, you would take your function in parentheses and divide it by your domain restriction. And it was a kind of a trick, if to use Kim's word, to get the calculator, the 84, to only graph within a specified range. Well, at least and that worked, and that's great, and we just kind of explained that away with kids. But with the Nspire, I can go in here and use the such that symbol, and I want to go from 0 less than or equal to x less than or equal to, what's my number, 4. So now I know I'm not getting all of the excess graph, but I'm also not seeing it. So I know I see a bit of the graph here near x equals 0, and it quickly goes off the screen. But I don't need to go from -10, and I don't need to go to 10. So the quickest way to change, this is one of the things I love best about the Nspire, is I can quickly change the window and I'm going to put 0 in for the minimum along the x. Now, I could press enter, and it would only change that, but I'm not going to press enter. I'm going to hit tab, and it moves me to the max. 6.67 is not high enough, so I'm going to try 100. I don't know if this is enough or not, but I'm going to tab it and see it. Oh, it is. And I don't need to go out to 10. I can go out to 4. I've probably gone too far, but, oh, I hit 40 there. I don't want 40, I want 4, sorry. And now I'm seeing the entire domain of this graph, and I'm seeing it in a friendly window, and I've done it fairly quickly. So my concern, or my question now, is I need to figure out when does this graph exceed 60. So all I'm going to do is graph the line 60. So if I hit tab and graph the horizontal line, I don't know what Mike just said. Okay, anyway, I wasn't watching the chat. I now have a 60 horizontal line at 60. And I can quickly see that there are times when the object is exceeding 60 miles an hour. So I don't think any of this is calculus right now. This is algebra. I mean, this would be algebra 2, or I mean, if you decide to use a cosine function pre-calculus. But I'm looking for, I have a function with restricted domain, and then I'm looking further in there. I don't want to, it's not the right term, but a subdomain that meets a certain criteria. So I'm looking at it in context, and if I were to do things like this in my Algebra 2 classroom, they would not be freaked out, because to be able to answer the actual calculus of this question, all they have to do is find these 2 points and then do an integral. But that's for the calculus teacher. But up to this point, I think anybody can do this. So I want to find those intersections, and I could do the analyze graph, find intersection, but I'm going to go ahead and do it a different way that I like to do. It's called using geometry under points and lines. You can do not that. Okay. Geometry, under geometry, points and lines. I want to do intersection points because I love to make the connections whenever I can. So if I do this graph, I get both of them right away, and I know that I use the phrase subdomain is from 1.87 to 3.52, which of course, if you're a calculus teacher, I know, I don't have enough decimals, but that's not our point.
But you can fix that.
I can easily
fix that. How do you fix that? How do you fix that right now? This is the one skill that I have been reviewing. So you hover.
Yep.
And then you press the little plus symbol. You do have to get out of your.
If I hover on it, I had to hit here, hovering and plus, not plussing.
There you go. Whoops.
I actually selected.
Yeah, you have to hover, and then on the computer, you actually have to hit the computer keypad. You can't do it on the keypad.
Yeah. Oh, so anyway, I can go under the attributes and change the accuracy there. So
I
can't change that.
Hover and plus. Yeah.
So all right. Anyway, so I'd have to hit the plus key on the keyboard. Anyway, all right. So I think that takes us through that. I don't want to belabor the calculus too heavily, or do you want me to do it? Anything else?
No, I think we're good. I think we have just enough time to do a rational example.
Okay. Yeah, Kim. I'm going to transfer Kim. Kim's going to look at the domain issues with rational functions using the 84.
Cool. All right. So the example that I want to give is I want to talk about this x of t, which is t cubed minus 8, all divided by t minus 2. And yeah, there's t's up there, and it's x of t, and in the BC calculus world, that's like half of a parametric. It could be okay, but kids don't like those x's, and they definitely don't like t's. It's always fun at the beginning of the year going, I don't like the right t because it looks like a 1 or whatever it happens to look like. I'm like, well, you got to figure that out.
Yeah, I put this in our study. I'm going to straight up lie. I put this in as the option, and neither Mike nor Kim were thrown by it, but my students would have given me all kinds of grief for this, especially because of the use of x as the function label. But they did that. They do that all the time. They use weird letters. You saw V sub Q in the previous problem. Don't use F as your only function name, please, please, please.
Yeah. So for this problem, you know, as math teachers, we know that the issue happens to be where. And hopefully we're saying when t equals 2, we have this division by 0, we would expect to see something there. So I am hoping that this is going to work. So this is my old graph that was here. And what I did is I saved my emulator with this example already on here. So this is example 2, rational function. Hopefully it's right. And that kind of saves us the time, so I don't have to reset all this up. So this was a file that was sitting on my desktop with my TI-84 teacher software. And lo and behold, here's this example, x cubed minus 8 all divided by x minus 2. And so I just inputted that in there. And I'm going to go ahead and look at the graph. I already made it a pretty graph. Now, you don't necessarily know what pretty graph it was. So let's go ahead, and there's a button on your TI-84 where you've got these multiple screens, and you do have to refresh them. So there's the equation I'm talking about. There's the graph I'm talking about. And is it going to let me build this up? No, it's not. But I also have the window. And so the window that I chose is going from -10 to 10 and from -5 to 30. And it kind of looks like a parabola, which isn't necessarily what I was expecting. I was expecting
that's not what I
cubic.
expected. I was expecting asymptotes.
Yeah, expecting something else other than that. And so some things that we could try. So but my students, I would say, well, what's happening at 2? So we're going to trace it. And we're going to say, well, what is going on at 2? And there's nothing there. Like, what's going on? And just having that conversation with them, well, what is going on? Well, if I go a little bit to the left, I have an answer. And if I go a little bit to the right, I have an answer. But I don't have that answer at 2. And the only way is I'm going to get that with this window is if I actually put that in there. So there is no asymptote because you have a removable discontinuity in this graph. So what would be another view that you would want to see in this? And I'm hoping someone's saying table.
Yep. You like tables.
You know what? I will tell you that when I first started teaching calculus, and I don't know how many years ago that was the one thing that I noticed that was missing in my teaching. I did not have my students.
No, I agree with you.
Yeah, I did not look at things numerically. I didn't look at them in a table. And so I made a mission of using Control-T on my Nspire once a week, or using the table on my 84 at least once a week just for the first year, and it was overkill. But that got me to look at it in the appropriate places at times. And I need that trick.
Kim, before you finish, I promised that I would have you show them how to save the emulator state and load it again, because a lot of people are liking that, commenting and liking that in the chat. So maybe show them how you save the emulator state and then again how to reload it.
I would love to do that. So really my only point here was to look at the table, and the way I had this table set up, you can definitely see the error looking at the whole numbers. If you press the plus key, you read your screen, you can change the table set for different things, and then you just have to move around. So that's something that I didn't necessarily pay attention to, and it's just right there. So right now I've changed something in the screen. I am just actually going to do one more thing. I'm going to say alpha F4, and I'm going to do Y1, and I'm just going to add 1 to that, and I didn't do the other notation. So not a big change.
That's okay.
But when I go not into file, it's an action. I can save this emulator state. So whatever state I'm in right now, whatever's on the screens, I can save it. And it's going to my desktop because that's where I have things set up. And I'm going to save it as webinar example, and that's where it's going to go. Yay me. It's saved. I am going to clear everything on this calculator right now, so I'm going to reset, and I'm going to reset all RAM. Yes, I really want to do this. And proof, nothing's here right now, and I do have to reset these. Well, maybe they're not going to do that. But now if I go back to action, I can load my emulator state. And you know what? I'm going to go back to my original rational function. It's example 2. Yes, I want to load that emulator state. And here's where it was. And I can now go put these back in here. I can look at a graph. And that's one way as a teacher, you can just start first hour here. You can start second hour here. You can have your 3 examples and just load them up. Once your kids know how to use a calculator, they don't need you to tell them what buttons to press. And so it's a time saver that way. So does that work?
Yes, that's exactly what they were asking for. So that gives us about 4 minutes, and Mike needs, I think, about 3 of them. So I think you should transfer control back to him if you're okay.
I think that would be a great idea. That was fun. All right.
Thanks so much, Kim and Corey, for everything you shared so far. If you have any last-minute questions, please try to get those asked. I know they'll do their best to try and get some of those questions answered. Right now we have available on our website, you can learn a little more about the extra credit contest for teachers. It's a way that you can earn points by doing things that you're probably already doing in your classroom, or things like what you're doing tonight, such as attending a webinar. So you can, again, visit our website to learn more about that extra credit promotion. If you want to enter the code from tonight's webinar to earn some points, tonight's code is domain range. It's all one word. So let me type that in a chat window. Domain range. It's not case sensitive. Again, that will earn you some points, and those points will enter you in different drawings. So please feel free to visit our website to learn more about the extra credit promotion. As Kim mentioned earlier, the T-Cubed International Conference is coming to Dallas mid-March. It's coming up quick. It's a great place to connect with other educators like Kim and Corey and myself that are like-minded and excited about teaching with technology. We always learn a lot at the conference each year, and we really hope to see you there. So you can learn more about the conference by visiting our website. There is special promotion pricing, I believe, available for the next few weeks here as an early bird registration. Also, Kim mentioned that one lucky winner tonight is going to receive a conference registration to that T-Cubed International Conference, and tonight's lucky winner is Leah Condon. So, Leah, congratulations. Again, we hope to see you, as well as everyone else, at the T-Cubed International Conference. And Leah will be in touch over email in the next couple of days to give you a little more information. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, so we really hope you share your thoughts in the post-webinar survey. We had some great conversation tonight in the chat window and the Q&A window. Feel free to continue that conversation on any of the major social media outlets. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents that were used tonight by Corey and Kim. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Lastly, if you're in need of some post-webinar follow-up, I know some people were concerned about possibly updating their operating system on some of their technology. Lots of different ways to do that. One way I saw someone mention you can give TI a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. We'd love to hear from you if you have any questions. Thanks so much, Corey and Kim, for everything you shared tonight.
Thank you for having us.
And thanks, everyone, for joining us. Sorry, Kim, go ahead.
I was going to say it was a great evening. Thank you.
That it was, I agree. Thanks for joining us, and we hope to see you back online real soon. Have a great night.